You are listening to The Vocal Technologist. Spoken tech for your ears.
When you sit down to work, are you actually, building features? Or are you just perpetually playing whack-a-mole with cloud chaos?
That's a good way to put it.
That really is the core challenge in cloud engineering right now. The complexity is just exhausting, and it's why everyone is looking for tools that actually restore some control.
Absolutely. That tension between building fast and operating stably, that's the defining characteristic of the landscape today. Every modern organization is facing it.
Right. And it's not just complexity, it's also intense scrutiny on budget and on reliability.
Exactly.
So that's what this conversation is all about. We want to synthesize the biggest shifts happening right now to give you the context for everything from automated cloud governance to, the brutal lessons we're learning from major outages.
And we're really going to look at how the modern stack is, well, it's forcing us to adopt architectural discipline and seek crystal clear visibility.
Okay, so we've broken it down into three key areas.
Right. First, we'll look at how AI is evolving. It's moving past just coding assistance to become a genuine operational agent in your cloud.
Then we'll get into the crucial strategies for enforcing control, managing infrastructure drift, and, importantly, learning from failure.
And finally, we'll dive into why unifying your observability using standards like OpenTelemetry is really the only way to quickly see past a system symptom to find the underlying cure.
Okay, let's unpack this. The biggest theme isn't just AI helping us write a few lines of code, it's AI running the operational elements of the cloud for us. We're moving toward what a lot of people are calling agent-centric operations.
And what's fascinating here is how the major platforms are adopting this model. Take Azure Copilot, for instance. It's evolving into what they call an agentic interface.
And what does that mean in practice?
Well, it's not just about suggesting a config change. It's about automating really complex tasks, like a full cloud migration or continuous optimization, or even just first-line troubleshooting and governance checks.
And for me, this is the differentiator. This is what makes it feel less like a helpful bot and more like a trusted coworker. The fact that these agents' actions are rigidly aligned with organizational policy.
Right. Your RBAC rules, your compliance standards.
It promises policy adherence that's just baked in.
Exactly. Baked in. So to give you a tangible example, if an engineer tries to provision a storage bucket without the mandatory encryption tag or uses a forbidden network setting, the agent doesn't just issue a warning.
It actually stops them.
Based on the defined policy, yeah. It either forces compliance or just blocks the deployment entirely. This shifts that operational workload, all the repetitive, policy-heavy work from human engineers to agents whose actions are consistently auditable.
That capability, though, it immediately raises the issue of trust and knowledge accuracy. I mean, if the AI is doing more, where does it get its verified information? We all know AI still hallucinates.
Which is where something like Stack Overflow's enterprise evolution Stack Internal steps in. Stack Internal is designed specifically to confront that hallucination problem. It does it by blending AI automation with human validation. It creates this continuously improving, secure internal knowledge ecosystem, a single source of truth for the enterprise.
And its defense against the dreaded AI hallucination is the MCP server, right?
That's the key part, the machine comprehension and prediction server. It connects your internal tools and copilots directly to content that has been verified by your own internal experts.
So it drastically reduces the likelihood of the AI just making up answers based on some stale wiki page from 5 years ago.
Precisely, which of course fundamentally changes how developers have to approach their work. It requires a real human workflow shift to get the most out of these tools.
We saw a review that broke this down into the 4 Ps for developer productivity: prompting, planning, producing, and refining.
Yeah, and while the AI handles the producing part at incredible speed, the real insight is that the high-leverage skill for the human engineer has moved entirely upstream.
It's all in the setup.
Absolutely. Move the developer from being, just a typist to more of a critical planner and an editor. If you don't break down the complexity into actionable chunks or manage the context you feed the AI, you don't get fast code. You just get a fast, complex mess.
So AI helps us write and govern code faster. But speed doesn't matter if we push a faulty configuration that breaks the whole system. Speaking of which, we have to talk about the massive reliability lesson from that Cloudflare outage last month.
Oh, that was a huge global event.
Yeah.
It took major sites like X, ChatGPT, and Shopify completely offline. And what's chilling is that the core cause was, well, surprisingly common.
A single configuration change.
A single, albeit very impactful, configuration change. It caused their bot management system to exceed its internal file size limit.
And that triggered a catastrophic cascade of HTTP 5XX errors across every single dependent service. It's a perfect illustration of how easily a minor internal issue can become a global disruption.
And the takeaways for you listening are pretty clear. Organizations have to rigorously test dependencies using fault injection. You need robust health checks across the entire stack.
And you have to actively identify and mitigate every single point of failure. You have to assume even rock-solid systems will eventually fail in some weird, unexpected way.
You really do.
That discussion leads us directly to infrastructure control, and here's where it gets really interesting. The whole infrastructure as code world is still dealing with the fallout from HashiCorp's license change, the Terraform versus OpenTofu fork.
That fork was a pivotal moment for open source governance. Terraform shifted to the restrictive business source license, while OpenTofu went under the Linux Foundation using the very permissive MPL 2.0.
And the choice isn't just philosophical, is it?
Not at all. OpenTofu is gaining ground because it offers native state file encryption, whereas Terraform still relies on external solutions for that critical security layer.
So for platform teams, the decision really hinges on their long-term risk tolerance, their governance requirements, and whether they prioritize an established name or a truly open source community.
And whichever IEC tool you choose, the battle against infrastructure drift is constant.
Can you define drift for us quickly?
Sure. It's when the actual state of your live infrastructure silently diverges from your written configuration code. And it's a constant, silent killer of reliability.
It just immediately opens the door to security gaps, compliance violations, and unexpected costs.
Sure. When resources are scaled up but never scaled back down in the code, the solution isn't magic, it's just continuous detection.
So running Terraform Plan regularly, or using specialized tools like Drifthill or Spakelift to automate alerts.
Exactly.
We're also seeing more sophisticated ways to manage rollouts. For instance, the Pulumi Kubernetes operator, the PKO, now integrates with a tool called Cargo.
What's great about this is that the PKO manages your infrastructure definitions as Kubernetes objects. This allows Cargo to systematically push them through promotion stages, just like an application deployment pipeline.
So you get controlled, verified, multi-environment rollouts of infrastructure changes, which is huge for stability.
Massive.
And that focus on control, it extends right down to the networking layer. For security-conscious organizations, AWS has introduced new VPC encryption controls, and this is a huge deal.
Oh, yeah. This new Amazon VPC capability lets you audit and enforce encryption in transit for all traffic, both within and across VPCs in a single region.
And there's a monitor mode and an enforce mode.
Right. You can start in monitor mode just to get visibility into any non-compliant plain text traffic, and then you can shift to enforce mode to ensure all future resources are created only on compatible encryption mandatory Nitro instances.
It's impressive how much centralized control we're now demanding, but, there's a small philosophical counterpoint we came across, this persistent love for Linux. Even as we add all these layers of complexity and control, there's a persistent appreciation for Linux's unmatched freedom, accessibility, and longevity.
It really highlights the tension between classic Unix principles and modern complexity. I mean, if we're going to enforce controls like that VPC encryption, we also need to respect the simple, stable foundation underneath it all.
Right.
Linux remains valuable because it allows for extremely minimalistic distributions and still provides a reliable base that's decades deep. We need the new control tools, but we shouldn't lose sight of minimalism.
Well, we can't control what we can't see. Let's shift now to our final segment, turning chaos into clarity. And that often involves a pretty fundamental shift in your monitoring strategy.
Yeah, the old days of fragmented vendor-specific tools just are not cutting it in the multi-cloud world anymore.
So this is where OpenTelemetry, or OTel, comes in.
Exactly. It's a CNCF graduated project. And its whole goal is to unify visibility across these fragmented multi-cloud environments. So collecting traces, metrics, and logs consistently across AWS, Azure, GCP, you name it.
The major benefit being that it lets developers treat observability as just another part of their platform engineering strategy.
Right. They can focus on building features, not wrestling with how to collect telemetry from 5 different agents, because OTel standardizes that whole process.
And that unified visibility, it allows for some really powerful monitoring use cases. I mean, even for foundational systems like Kubernetes, the focus is shifting.
Yeah, while we still rely on Prometheus and Grafana, monitoring now has to prioritize business-aligned signals, ensuring consistent labeling and rapidly correlating metrics with logs and traces to enable effective automated scaling.
Things like HPA and VPA.
Exactly.
This is the vocal technologist, and what's particularly fascinating is seeing how observability is immediately being adapted for this new AI era. We need to monitor the agents themselves, the very things we rely on for automation.
That's so critical for debugging and for cost. Using tools like Openlit and Grafana Cloud, engineers are now monitoring AI agents deployed on platforms like Amazon Bedrock Agent Core.
And they're tracking things like token usage and model performance.
Yes, which are essential for debugging complex production issues, and crucially, for optimizing cost. An inefficient AI agent can rack up massive bills surprisingly quickly.
And the monitoring tools themselves are getting smarter about correlation. Grafana 12.3 introduced new cross-store correlations that really change the debugging workflow.
This is a massive quality-of-life upgrade for any engineer. You can now jump from a specific trend in a chart directly to the related logs or traces with a single click.
And the tool automatically carries the time range and all the labels.
Everything. It eliminates all that tedious, error-prone copying and pasting we all used to do, trying to line up 3 different data sources.
Okay, to wrap up visibility, let's look at a case study in efficiency. Yelp's strategy for S3 server access logs at scale. Improving data security and troubleshooting, it requires extensive logging, but the raw log volume can just crush your storage budgets.
And make queries impossible.
Yeah.
So Yelp decided to convert those raw logs to the Parquet format. The results are, well, they're astounding. They achieved an 85% reduction in storage size.
85%, and they reduced the number of individual objects in their buckets by 99.99%.
I know, it's incredible.
We're talking about achieving compliance and saving a ton of money by just fundamentally changing the data format. This shows platform engineering isn't just about managing Kubernetes, it's about rigorous data transformation.
It's proof that sometimes the biggest efficiency gains don't come from buying a new tool, but from restructuring the data you already have.
So after all that, what does this all mean? The modern DevOps landscape requires this unprecedented internal coherence. We are demanding more intelligence from our core tools, from AI agents that actually understand your policies, thanks to platforms like Stack Internal and Azure Copilot, to a real commitment to unified visibility through open telemetry. That ensures when things inevitably go wrong, like that Cloudflare outage, you have the knowledge to fix them fast.
And it really speaks to the ongoing, often frantic shifts in engineering management expectations. We saw a review recently that questioned if good engineering management is just a fad because the expectations swing so wildly based on the industry cycle.
It's so true. In the 2000s, it was about navigating siloed teams for approvals. In the 2010s hypergrowth era, it was all about people, leadership, and culture.
But post-2022, driven by economic pressure and AI adoption, the focus is right back to hands-on, execution-driven leadership.
So the takeaway there isn't cynicism, it's practicality. The only durable path forward is developing foundational, long-term leadership skills. The ability to plan, define, and communicate, regardless of what the industry is currently rewarding.
Right, whether it's navigators or hands-on executors.
Which brings us to our final provocative thought for you to mull over. If AI agents are taking over automation, security enforcement, and first-line troubleshooting, what is the new high-leverage skill for the human engineer in the next 5 years? Is it only planning, or does it fundamentally shift toward defining, auditing, and enforcing the system's guardrails? Something to think about as you plan your own learning path.
Spoken Tech for your ears.